Let's balance the familiar reaction between hydrogen carbonate ions and any acid. We'll get the equations that we need in order to understand the reaction. Sodium hydrogen carbonate, which is known as baking soda, reacts with either a strong or a weak acid to form the sodium salt of that weak acid, which I just called sodium xide here, water, and carbon dioxide gas. We want three things: the complete balanced equation, the complete ionic equation, and the net ionic equation, which tells us what's actually going on. We will use hydrochloric acid in our example here, so that the dissolved product that is produced is not sodium xide, but sodium chloride. First, we have to write the reactants and products. Hydrochloric acid, of course, is the binary acid HCl. Sodium ions are Na+. Hydrogen carbonate ions are HCO3 with a -1 charge. That means to balance those charges in the compound sodium hydrogen carbonate, we write NaHCO3, a ratio of 1:1 of the two ions. The dissolved product that is created is sodium chloride, NaCl. The water that is produced, of course, is H2O, and the gas that is produced is carbon dioxide, CO2. The equation then is NaHCO3 plus HCl reacts to form NaCl plus H2O plus CO2. And if you count atoms, you see that this is a balanced, full chemical equation. Now, from that balanced, full chemical equation, we'd first like to classify it, so we know whether it is an oxidation reduction, an acid-base, a precipitation, or a simple decomposition. It turns out, we'll see in a minute, it's two of those. The reaction is being done in water, so we put the sodium hydrogen carbonate and the hydrochloric acid, which are both very soluble and will break up as aqueous solutions, and the same thing with the sodium chloride. The water is going to be a liquid, the carbon dioxide is a gas. So what is really happening is this. First, the sodium hydrogen carbonate is reacting with the hydrochloric acid to form sodium chloride and carbonic acid. That's an interesting way of looking at the reaction. And the carbonic acid that is produced immediately breaks up into water and carbon dioxide, because this is a very high energy compound compared to water and carbon dioxide gas. Equation number 1 is therefore an ion swap. You can see the sodium ends up being paired with the chloride, so that's the outie, and the hydrogen ends up, hydrogen ion ends up stuck to the hydrogen carbonate. That's the Ne, and that's hydrogen carbonate here, or carbonic acid, as the other product. So this is an ion swap, and this is a simple decomposition. That means that what we have is an acid-base reaction. Let's write this as an ionic equation. Well, both reactants are dissolved. Both reactants are going to dissociate completely, because this is a strong acid and this is a salt, and salts dissociate as they dissolve. So here are our ionic reactants: sodium ions, hydrogen carbonate ions, hydrogen ions, and chloride ions. The sodium and chloride ions are not affected by the reaction, and so they show up as, in essence, dissolved sodium chloride. The other product is carbonic acid, and we see that here in what we now have is the total ionic equation. The ionic equation is sodium ions and hydrogen carbonate ions dissolved in water react with hydrogen ions and chloride ions dissolved in water to form sodium ions and chloride ions dissolved in water, liquid water, and carbon dioxide. That is the full ionic equation. Now, the net ionic equation tells us what is actually happening. It must be balanced for mass and charge just like any other chemical equation, but it represents the kernel or the core of the chemical reaction. And so here is the full equation. We write the ionic equation from the previous work that we did. And now we identify the ions that are the same on both sides. They are called spectator ions. We see them here. Sodium appears on the left and on the right, and the chloride ion appears on the left and on the right. No change there. Therefore, there is no reaction actually going on with those ions. So the spectator ions being eliminated, we have the net ionic equation. The hydrogen carbonate ion, or bicarbonate ion, is reacting with hydrogen ions to form carbonic acid, which splits up into water and carbon dioxide gas. So we have our net ionic equation that tells us what is actually happening. As you can see, it's balanced for mass and charge, just like any other chemical equation.